Before we start the video, let me give you a brief introduction about myself. I'm Chandresh Mahajan, who is founder and chief educator at Exergic, which is India's most trusted and comprehensive institute for online gate preparation. I got an All India rank 37 from Gate Mechanical Engineering, and I am an ex Indian Oil officer, having 6+ years of teaching experience as of now. To know more about our GATE courses, you can contact us on these details. Also, you can download Exergic Gate Preparation app from Google Play Store. The link is available in the description of video.
Now let us solve another problem from friction. The problem says that a semi-cylinder of 1 kg mass lies on a rough inclined plane as shown. So we have a semi-cylinder, as you can see in the figure. Its mass is given to you 1 kg and it lies on a rough inclined plane as shown. Let's cover each and every keyword. Which lies means it is at rest. It is lying there. It is at rest. So this is, although a very small keyword, but it tells you something, right? On a rough inclined plane means the surface is rough, friction is going to be present there, and it is inclined plane. So as we can see that we have an angle of inclination of 10 degrees. The question further says that if mu s is equal to 0.3, so this is the rough surface. So obviously mu s is given for this interaction of cylinder and inclined plane. The coefficient of static friction for inclined plane and the semi-cylinder is 0.3. Then find out the angle of lip theta. This is the angle theta of its base AB. This semi-cylinder has a base AB. Although base is currently on the top, not on the base, but this is called as the base of AB. Sorry, the base AB of semi-cylinder. So this angle theta you need to find out. Now this question may look like a very easy, straightforward question to you. And it is an easy and straightforward question, but this question has some of the places where you can commit silly mistakes, especially when you are in exam pressure or maybe you are solving such questions for the first time. So that is why pay attention to this question, and the best way would be that pause the video as I generally ask you and try to solve this question on your own and try to reach the answer. And then play the video. I am obviously continuing the discussion. Then play the video and watch me how I solve it, and I will tell you what are the places where you might have done some mistake. So question is pretty much easy, straightforward. Since it says that it lies on a rough inclined plane, this small keyword is very important. It gave you the idea that this semi-cylinder is in static equilibrium, right, under the action of all the forces acting on it. What are the different forces acting on it? Point 1, weight, right, the number one force acting, which is weight, because mass is given to you. Next is going to be friction. It is a rough inclined plane, right, so friction is going to be there, and obviously it is resting against a surface, so normal reaction will also be there. So these are the three forces which are acting on this particular semi-cylinder. Since it is at static equilibrium, these three forces will obviously be concurrent. Now let us draw the free body diagram of this, and then I will tell you the first point where you can commit silly mistake. Now where does the weight act? Weight acts on center of gravity. I have shown the center of gravity of this body here. How do I know that it is going to lie there? Look, any semi-cylinder you have, to locate the center of gravity, you just need to draw a line perpendicular to the base. This is AB, perpendicular to the base, passing from the center. On that line only center of gravity will lie if the body has a uniform density, mass is uniformly distributed. And if nothing is mentioned to you in the question, you have to consider the mass to be uniformly distributed. I have already told you that in many questions. So G is going to lie on this line which is perpendicular to AB. In this case, a line is passed, this dotted line is, let's say, perpendicular to AB. So on that line only G is going to pass. Now let me tell you where some of the students can do silly mistake. Some of the students can think or they can draw in the diagram that this point where the perpendicular line is touching the semicircle is the same as the contact point. Some of you can do this mistake. Some of you may have done this mistake while trying to solve the question. This is not correct. Point of contact is different. This perpendicular line passing through center of gravity is touching the semicircle at a different point. Let me tell that to you by showing an exaggerated diagram. I am drawing an exaggerated diagram. I am assuming that theta is very large. I am assuming just for the diagram. So this, maybe this is how this semicircle is touching it. Okay, just a second. Now look at this diagram. In this diagram, this is the contact point. This is tilted by theta. What will be the line perpendicular to AB? This line will pass somewhere like this. But the contact is not there. Contact is here at this point, right or not? So these 2 points, this point and this point, these are 2 different points. Question can give you a diagram where you can get confused or you may not be able to think in that direction. And if you assume this point and this point to be the same, the answer theta will be equal to 10 in that case. You will get an incorrect answer in that case because you have assumed that this line and contact point are same. Means this AB will become parallel to the inclined plane in that case. And in that case, theta will become equal to 10 degree, which is incorrect answer, which is not the correct answer. So this is a silly mistake. Try to understand and visualize the problem before you try to solve it. Especially in case of diagrams, I have already told you that. So in this case, these 2 points are different. Point number 1. Point number 2, when we try to draw the free body diagram, 3 forces are going to be there. I have already told you. Weight is going to pass from center of gravity. Normal reaction will be perpendicular to the common normal at the point of contact. This is the point of contact. Common normal will be perpendicular to this surface, And where it will pass from? Will it pass like this or like this or like this or like this? I have already told you that as well. That whenever you have a circular, semicircular or any circular arc in contact with any surface, the normal reaction will always pass from the center. So in this case, the normal reaction will pass from the center. From here, normal reaction is going to pass. What will be the direction of friction? Here. In the upward direction. In this direction, friction is going to act. Now, this is something which we will discuss in detail in rolling, right? Because there are 2 types of motion possible for this. Currently, it is at rest. It is not moving. But maybe it is trying to roll or maybe it is trying to slide. Whatever is the possibility here, from both the considerations, the friction direction will be upward. Some of you may not be able to understand it, but once we cover the rolling unit, you will get these things very easily. Don't worry about it. Okay. So for this question, maybe you take the sign of friction wrong. That is rare, but some of you may do this mistake, but don't worry about it at all. After we will cover rolling, you will be easily able to do these things. These are very basic and small things. But let's not talk about rolling. Let us assume here that this body as a whole try to slip down. This body, this semi cylinder try to slip down. So if it is trying to slip down, friction is going to act upward. So don't consider rolling, reject it. Just consider sliding here, and using sliding also you can tell that the direction of friction will be in the upward direction, up the inclined plane. So three forces: weight, the direction we have determined; vertically down, weight is always going to act vertically down; friction, up the inclined plane; normal reaction is going to pass from the center of this semi-cylinder. Let me draw the free body diagram of this case, and then we will proceed with the problem. So this is the free body diagram that we have. Normal reaction passing from the center, friction along the inclined, weight acting in the downward direction. Let me ask you one interesting question here, although it's a very simple one, that from where this weight force will pass, from which point this weight force will pass. Since this body is in static equilibrium under three forces, they have to be concurrent forces passing from the same common point. Normal reaction and friction are intersecting at this point. Both of them are passing through this point of contact. So obviously weight also have to pass from the same common point. Then only these three will be concurrent forces. So this weight force has to pass from the point of contact, from this point. This is how the weight force will be shown. The right orientation of weight force will be in such a manner that it passes from this point. Then this body will be under equilibrium, static equilibrium, under the action of these three forces. Now this inclined is acting is at an angle of 10 degree from the horizontal. So this force, which is normal force, which is perpendicular to inclined plane, will be at 10 degree from the vertical. I have already told this funda to you a lot of times with a lot of different ways, right? So I think without using any geometry, you can directly determine that if this line is making 10 degree with the horizontal, normal, but its perpendicular will make 10 degree from the vertical, right? So we know the orientations as well. Now let us apply the concept of static equilibrium of summation of forces along two perpendicular axes should be equal to 0. Now we can select this axis as x-axis, this axis as y-axis, but it is better to take x-axis along the inclined plane like this and y-axis perpendicular to the inclined plane. Again, this funda also I have told this already in a lot of places, that why we use, where we use. So for this case we are going to consider inclined plane to be, means x-axis to be along inclined plane, y-axis normal to the inclined plane. Okay, and considering those axes, if we apply summation fx is equal to 0, then the forces, what forces will get balanced? This W will be having a component in this direction, right? If, let me show F here, it will be easier for you to analyze in that case. This is 10 degrees. Right? So FF is acting up the inclined plane. W is having one component down the inclined plane. W is acting like this. So W will be having one component like this, opposing the normal reaction, other component like this, opposing the friction. So for static equilibrium, FF should be equal to W sine 10 degree, right? This component will be W sine 10, right? So let us equate them. We will get FF is equal to W sine 10 degree. Mass is 1 kg. G value is not given, so we can consider the G value as 9.81 multiplied by sine 10. This will give you directly the value of friction, which I think will come out to be 1.703 Newton. But all of you will not be able to get this value. Some of you will get a different value of friction here, a value higher than 2.8 something. What is the reason for that? Let me tell you. Some of the students, they would have applied summation Fy is equal to 0. Okay. If you do that, N will be balanced by cos component of W, means W cos 10 degree is equal to normal reaction. This is what they will get. And then they will think that if we want to calculate force of friction, let us apply mu N. Right? This is something that we know, that F is equal to mu N. The value of N you will put here. Mu is 0.3. W is 9.81. Cos 10. You solve it, you will get another value of force of friction which will be incorrect. This is the correct value. Why? How are you getting two different values of force of friction for the same problem? I have told this to you already. We have solved similar concept, a question on similar concept before. I have taught you that concept as well. The value of force of friction that you get from mu N is the limiting value of friction, limiting value of force of friction, mu S rather, right? The maximum force that the friction can oppose, keeping the body at rest. If the force you apply is less than mu Sn, the body will not move. But it does not mean that the friction is equal to mu Sn. Friction in case of a body at rest is equal to applied force. The maximum force that you can apply keeping the body at rest is equal to mu Sn, right? I am not telling this concept in detail here. I am just reminding you, revising you that concept which we have already discussed. So this is again a silly mistake which students do, that they directly apply mu N as force of friction. Don't do this, do not develop this habit. Always try to apply static equilibrium to get the force of friction. You can even write this down in your notes, that apply the static equilibrium concept to find out the force of friction. Do not randomly apply mu N or any other funda you can apply, but do not randomly apply mu N to find out the acting friction, the value of friction which is actually acting. This is just telling you the limiting value of friction, the maximum friction that a body at rest can apply, or the surface can apply. Okay. So in this case, if you did this, it is an incorrect approach. So right answer for force of friction will be this one. If the question just asked you the force of friction and 4 options were given and another option that you get, the wrong one, was also there, some of you may have done that mistake. So this is the value of force of friction. And now let us try to find out the value of theta using this value of force of friction. And for this problem, I am slightly modifying the diagram. The diagram is still the same, but to explain it to you, rather than joining this with this, means the center with the point of contact, I have joined the center with the center of gravity here. Okay. What will be this angle? Can you tell me? This line, this dotted line, is perpendicular to AB, right or not? I have already told you that it will be perpendicular to AB passing from G. AB is making theta from the horizontal, so its perpendicular will make theta from the vertical. This is the perpendicular line. It will make theta from the vertical or theta from the W vector, right? Now, why I have done this construction? Because the next condition that we are going to apply is summation of moment is equal to 0. If we apply summation Fy0, then I showed it to you, you will just get the value of normal reaction N, because W's component will balance N and W is known, N you can calculate. But question is not asking you n, question is asking you the value of theta. So for that we are going to apply the third condition of static equilibrium, the summation of moment 0. Now about which point you should take that? We are going to take that about point O, the center of the semicircle. You can experiment this for different points. Ultimately you will realize that it is a good choice that you take the moment about O, because if you take the moment about this point, all the forces will become zero, their moment will become zero. If you take it about this point, then W's component will obviously become zero. Only N and F are going to exist, they are going to balance each other out. That's it. You cannot get anything related to the value of theta. So to do that, O is the best point about which you can apply the summation of moment to be equal to 0. So if we do that, what are the forces that are going to balance each other? Because whenever we take moment about any point, forces balance each other, their moments balance each other. From point O, the normal reaction is going to pass, right? If you extend it like this, normal reaction passes from that point only. So that normal reaction will become 0. Only F and weight, force of friction and weight, these two forces will be present. And for static equilibrium, both of them have to balance each other. Force of friction is acting counterclockwise about O. This is how it is acting counterclockwise. Weight is acting clockwise. They both have to balance. F and W, both the values we know. But we can relate theta with W. That is why we took the moment about 0. About O, sorry, not 0, about O. I have just showed you that how W can be related with theta. And that is why we are going to take the moment about O. The anti-clockwise moment of force of friction going in this direction will be equal to force of friction multiplied by R. Let's say R is the radius. R is the radius of this, right? So this point to this point of contact, this distance will also be radius. So this is the counterclockwise moment of friction, should be equal to clockwise moment of weight. Weight is acting like this. Now again, one funda I will use from what I have taught you. I told you that whenever you have such case where direct distance is not known to you, it is easy to just break down the W into two components or any vector into two components. So here W can be broken down into W cos theta. W cos theta will be passing from the center O, and W sin theta will be like this. W sin theta, right? This W has been broken down into W sin theta, W cos theta. W cos theta is passing from the center only, from O only. About O we are taking the moment, so W cos theta's component will become 0. Only W sin theta component will exist. And this is trying to rotate clockwise. So W sin theta multiplied by this distance, OG. This distance. How much is OG? We know that for a semicircular body, if this is O, this is center of gravity, this distance between them is equal to 4r by 3 pi, right? So OG is that distance. So if just in case any of you don't remember this formula, he will not be able to solve the question easily, right? So OG is equal to 4r by 3 pi. R and R will get cancelled. R was also not given to you in the question. FF we have calculated 1.703 divided by W is 9.81 multiplied by 4 will come in the denominator, 3 will go, 3 pi will go in the numerator. This will be equal to sine theta, right? And when you solve it, the value of theta you will get as 24.144 degrees. Now this question, if you look at it, just look at the calculation. Such a simple calculation. Only two things you have to do, 2-3 steps, the question is solved. But if you look at the diagram, that involved some manipulation, right? Even if you look at the question, it is very simple, just two statement. But there are chances that you can commit silly mistakes here and there, drawing the correct diagram, knowing what is going to happen here, knowing what is going to happen here, the inclination, what is the location of the center of gravity, this perpendicular point and these points are different. All these things can confuse aspirants in exam pressure, especially if the diagram given is confusing. If the question gave you a diagram where AB seemed parallel to this, then it can get difficult for you to directly think of these things, that how the normal will be different than the point of contact. But now once you have solved this question, whatever question you get like this, any semi-cylindrical shape balanced on any inclined plane or even on any other plane, even the plane is horizontal but this semicircle has some weight added over it, whatever be the variation in the question, you will not stuck anywhere if you have followed what I told you, and whatever points I asked you to write it down in your notes and understand properly. If you have got those correctly, whatever question you get regarding the static equilibrium of a semicircle, you will be able to solve it very easily.